activating the thermal batteries. All systems are go. We have main engine.
What you are looking at right now is H3 launch vehicle readying for test flight number 1 to be launched from the Tanegashima Space Center with Daiichi 3 on board. And we are scheduling to make the launch at 10:37 or thereabouts. Good morning, everyone watching the live streaming. We will be providing you with a live broadcast of the H3 launch vehicle launch loaded with Daiichi 3. My name is Kotomi Mimura, responsible for PR at the JAXA at Tanegashima Space Center. I'm very much looking forward to the launch of H3 with you all. My name is Isao Kotani, I'm an engineer at JAXA, and I'll be providing you with technical commentary today. Thank you for joining me today. Kotani-san, we have finally arrived at this date, finally. And H3 project started back in 2014, so we are now in the 9th year. We are finally here. Now,
Today, this live broadcast is also available in English simultaneous translation. Please go to the link in the YouTube description.
So, what you can see behind us is the H3 launch vehicle. Yes, there it is. Finally standing there. And where we are right now is a place called Takezaki Observation Deck, located some 3 kilometers from the H3 launch vehicle. And Daiichi 3 is contained in the section called fairing at the tip of the launch vehicle. Now, Daiichi 3 is an informal name. In English, it is referred to as ALOS 3, Advanced Land Observation Satellite 3. Now, as for the weather today, beautiful weather today. We had a lot of overcast days recently, but it's a great day today. So there were a number of days with a lot of cloud covering, so we were feeling somewhat anxious. But let me read out the information from the Meteorological Agency. Now, based on the information released, the Tanegashima region is covered by somewhat of a high pressure, but the calm weather is continuing. And so there is no forecast that is going to have negative impact on the launch. Fine weather, and the 3 meters of the wind from the northwest and the 16 degrees to the temperature. So calm weather is expected to continue for a while. What are the conditions required for launch? Well, today we have a great fine day and wonderful weather for a launch. But we don't feel that there is any the issues with the weather for the launch, and we check various things when it comes to weather. Say, for example, the strength of the wind, amount of precipitation, or the condition of the cloud. If we have a cloud nearby, then what type of cloud is it? Is there any lightning or not? So we actually look at all these conditions, and only upon clearing all these conditions, then we make the decision that it should be okay. So the maximum instantaneous wind speed must be less than 20 meters per second. In terms of precipitation, it must be less than 20 millimeters per hour. That's quite a heavy rain, but at that rain, we will not be able to launch. In the case of a cloud, you may hear of a frost layer. There is ice grains contained in the cloud, and if that is very dense, then that could potentially cause lightning. And so we need to be quite mindful of that, and we check to make sure that these conditions are met. And so weather is one of the important conditions for launching these launch vehicles. Yes, that's right. Great looking weather today at this point in time, but we continue to check the weather condition until just before the launch. Now, towards the launch, there is a place called a Launch Control Center, LCC, that conducts various types of remote work. And we have a camera link to LCC, the Launch Control Center. And this is it, and making preparation towards the launch. So we have people standing up, we have people sitting down. Now, the Launch Control Center is the control center for the launch. It's one of the key units. What they do here is that they do various inspection until the launch. They will provide instructions. The fuel is fully loaded right now, but they were involved in filling the fuel. And so all the preparation from the launch, prior to the launch, is done from here. And also the condition of the rocket as to whether it is appropriate or not is looked at as well. The people sitting here are experts, and they are professionals of the various systems in the launch vehicle, and also the person overseeing the entire the process called the launch conductor is also located here. Now we are located about 3 kilometers from the launch pad. Why do we have to be so much far apart? Well, I was saying that the fuel is being filled, and the fuel is the liquid hydrogen and liquid oxygen. They are somewhat of a hazardous fuel. So when filling, just in case of the unlikely event of the accident occurring, so we actually secure a safety distance. So that's a radius 3 kilometers. So there are no one within 3 kilometer radius of the launch pad. And so the launch to control the center is done remotely as well. In the past, the launch control room was located very close to the launch pad. That was because back then the remote control technology was not all that great, but today you can do everything remotely now. And well, for H2A, we still have that launch control center that we used to use in the past as well. But 3 kilometers is the distance that we secure in order for ensuring safety. So what type of operation take place at the LCC? And they're continuing to monitor, and towards the launch, they're making the final preparations. And about 240 seconds before the launch, the automatic countdown sequence starts. In other words, switching of preparation would be done automatically. Despite it being automatic, it's not the case that people don't do anything. They continue to look at as to see whether there are any abnormalities, and if there is any issues, they will stop the launch immediately. The H2A rocket and H2B rocket, which is going to be retiring, in comparison to those, the staff number has been reduced. Now, I was in the LCC when we were launching the H2B, and I remember there being more people there. And now with H3, we have introduced many new technologies. We have also introduced many automated inspection and the schemes. So we have been able to reduce headcount. I think the number is probably about a half. But this is a test flight, and so as we proceed towards operation, we'll be able to reduce staff more, and maybe a third or fourth in comparison to H2A. That would be the target. And so the number of people will continue to be reduced. So let me introduce the schedule for the broadcast today.
Well, first, we will introduce the overview of the H3 launch vehicle, its mission, as well as the messages from viewers and businesses. Then, we will play a video of H3 launch vehicle history and background and introduce the flight sequences. That is the schedule for today, and today's mission is this. Well, first of all, lift off, and then SRP3 separation, and then fairing separation, then the first and second layer separation, and then finally a loss 3 separation. That is the sequences for today. So 43 minutes away from the launch, it is about to start, so I'm getting all excited. So now regarding this H3 launch vehicle, Kotani-san, could you please talk a little bit about it? Well, H3 launch vehicle has been developed by JAXA and Japanese businesses. It is really a combination of those efforts. A feature is that soon after we did the development, we wanted to use this for private sector business purposes. So from the design stage, a private sector had played a very important role. So since H2A, there's been a great improvement. Version up, I would like to call it. So it is highly reliable, and whatever satellite it is, you can mount it. So it is flexible, and also cost effectiveness has been improved as well. So when we commercialize this, not only Japanese satellites, but also we'd like to work with international satellites as well. So if you could look at the image projected, the length is about 63 meters, so it is quite big. Actually, this first flight, 57 meters, so there is a difference. The tip, called a fairing, there are two types. There is a short one and a long one. And it depends on the size of the satellite, you can change it. And this time round, we use the short one. So it is slightly small, 63 minus 6 meters, 57 meters is the length for the short one. The diameter is about 5.2 meters. And the size, you may not be able to understand this, it is about the size of a 20-story building. I just wanted to say how large it is, just to give an idea. If you look close up, it is so big that I cannot really believe that it is going to the space. Yes, you also saw some developments yesterday, so I have been watching H2B as well. So the size of the first layer is about the same, but the second one, H2B, is slightly narrower. So it is 5.2 meters all the way up. So it looks quite heavy, doesn't it? Yes, that's right. So far, H2A rocket and H2B rocket carried the word Nippon on their sides. Nippon means Japan in Japanese, but now it says Japan. Yes, that's right. The Japanese baseball team is doing quite well. So the word Japan is well known to a global audience. And we talked about making inroads into the global space as well. So we wanted to change the name to Nippon to Japan, which can be understood by international audience. This is quite meaningful. So the world this H2 rocket is launch vehicle is trying to realize, as well as a development journey. We have a video, so please enjoy.
私たちが携わる宇宙開発は1957年に旧ソビエト連邦現在のロシアが世界初の人工衛星スプートニクを打ち上げて以来60年以上にわたり続いてきました。宇宙開発の目的は多岐にわたっており、例えば宇宙という未知の領域を研究し、宇宙や惑星の成り立ちや生命誕生の秘密を解き明かす知的探求心の解明が最もイメージしやすいかもしれません。さらに今や当たり前となった天気予報や道案内、自動運転など私たちの生活に欠かせないこれらのサービスの実現には宇宙開発による技術が使われていることを皆さんはご存知でしょうか。地上の暮らしをより便利にするために生み出された技術が発展を続け、宇宙開発と交わりお互いを高め合う。宇宙開発はもはや私たちの生活になくてはならないものになりつつあります。私たちの暮らしと密接に関わる宇宙開発に欠かせないのがさまざまなものを宇宙に輸送するロケットです。では世界中にロケットが多く存在する中でどうして国産のロケットを新たに作る必要があるのでしょうか。それは日本が独自にロケットを持ち続けることで生まれるメリットがたくさんあるからです。例えば先ほどのような私たちの生活を豊かにするサービスを実現するには日本が適切なタイミングで必要な人工衛星を自在に打ち上げれる環境が必要になります。それには日本独自のロケットが必要不可欠になるのです。 H3 は現在運用中の H2A の後継機として今後20年間使い続けることを見据えた日本の新しいロケットになります。国内外問わず数多くの人工衛星を定期的に打ち上げることを目指し H3 を安定して使い続けることが目標となります。そのためには日本だけではなく世界中から選ばれるロケットを目指さなくてはいけません。 H3 は3つの要素、打ち上げたい時に打ち上げられる柔軟性、これまでのロケット開発で培った高信頼性、低価格の実現を目指し 誰もが宇宙空間を活用できる時代を目標に、徹底した利用者目線で使いやすさを追求していきます。2014年のプロジェクト始動から8年、途中にはメインエンジンの技術課題を克服するために2度の開発計画の見直しもありました。開発を主導した岡田正史プロジェクトマネージャーは H3 をこう語ります。
ロケットっていうのは地上のすごく劇的な進化を宇宙から支えるための、乗り物だと思うんですよね。H3 ロケットは構想から約10年のロケットです。打ち上げの成功がゴールではなくて、我々はその打ち上げの成功が出発点だと思っているので、早くこのロケットをデビューさせて世界中の方々から使っていただけるようなものにしたいと思っています。
さまざまな困難を乗り越え、ついに完成した H3 ロケット。試験機1号機の打ち上げはすぐそこまで迫っています。新たなるフロンティアへ、未来を背負った H3 が間もなく飛び立ちます。日本の技術で宇宙輸送をリードせよ。H3 ロケットのメインエンジンとして搭載されるのが今回新たに開発した LE9 になります。これまで日本が培ってきたロケットエンジン技術を集結するとともに、新たな技術にも挑戦し、 H3 が目指す柔軟性、高信頼性、低価格を高いレベルで実現することを目指しました。エンジンの燃料に液体水素、酸化剤に液体酸素を使い、搭載する人工衛星の重さや投入する軌道に合わせて LE9 エンジンを2機ないしは3機を束ねてロケットに装着します。 LE9 は H2A のメインエンジン LE7A と比べ推力が約 1.4 倍にパワーアップしたことで、固体ロケットブースターなしで衛星を打ち上げることが可能となりました。また重い人工衛星を打ち上げる場合には固体ロケットブースターをつけるなど、従来の H2A や H2B に比べて幅広い打ち上げが可能となります。このパワーの大きいエンジンを安くかつ信頼性を高く実現するため、これまでのロケット開発で得た経験と新しい技術をバランスよく取り入れました。その中でも特徴的なものを3つほど紹介します。まず LE9 で採用するエンジンの燃焼方式は従来のものよりシンプルな仕組みにすることで、より高い安全性を実現しました。またエンジン全体の部品点数を減らすことができ、これにより高信頼性と低価格を高いレベルで両立することが可能となります。次に LE9 には 3D プリンターで製造した部品がいくつも使われています。今までロケットエンジンには形が複雑で溶接やボルトを使った部品がたくさんありました。これらを 3D プリンターで一体成形することで大幅な部品点数削減、コスト削減を実現しました。そして電動バルブの採用でいろいろな作動範囲で燃焼することができるようになります。これにより燃焼試験の回数を大幅に削減することができました。このような最新の技術の粋を集めた LE9 エンジンがたどってきた道のりは決して平坦なものではありませんでした。 JAXA では2005年から約10年間技術実証を目的とした LEX エンジンの開発を行い、2014年から LE9 エンジンの開発が本格的に始まったのです。開発の段階ではさまざまな技術面での問題が発生しました。その一つ一つの壁に向き合い、生じた技術的課題を確実に解決するために、そして今後20年使い続けることができるロケットエンジンに仕上げるために、2度にわたり試験機1号機の打ち上げ計画を見直しました。
この LE9 エンジンは2002年から研究が始まってですので、ほぼ20年ぐらいの時間をかけて開発してきたエンジンになります。でもこの技術というのは 結構、厳格で、我々開発陣のその、願いとか希望といったものというのは、なかなかその、通用しない、思い通りにならないということが、結構ありました。ある意味その残酷な現実というものを突きつけられているという部分があります。ただ最後ですね、何としてもこの世界初のエンジンを開発させてやるんだという関係者の皆様、これは我々 JAXA だけじゃなくてメーカーの方とか部品のベンダーの方も含めた強い思い、そういったものが実を結んでこのエンジンの完成にこぎつけることができたというふうに思っています。LE9 エンジンの開発担当者として一点の曇りもなく自信を持って H3 ロケットの初号機に使えるエンジンを仕上げることができたというのは万感の思いです。
はい。
How did you enjoy the video? That was the overview of the H3 launch vehicle as well as the feelings of developers. So, Mr. Kotani, how have you been involved in the H3 launch vehicle? I worked with those who are in the video. So, about 10 years ago, I joined a team before the project was called H3 project. It was called Next Base Rocket or Launch Vehicle or something. I was in the concept team, so I wasn't able to imagine what would happen in 10 years' time, but still we were having all sorts of discussions. And now right in front of us, the complete version is there, so I am really speechless. So even before H3 launch vehicle wasn't called HS3, you were already engaged. Yes, that's right. So this is the Tanegashima Space Center. Do you know what it's called? Well, it's obvious. This is the most beautiful launch site in the world, right? Yes, that's right. I hope that viewers can see this. The ocean is very beautiful. Yes, this launch site tends to be near the sea or ocean. This is normal practice, but it is really close to the coastline, and you can see the ocean view. This is quite unusual. About half a year ago, I moved to Tanegashima Island, but even today, I'm always excited to go to work because I can see the beautiful scenery. You can feel refreshed, can't you? Yes, that's right. So now it is 10:08 a.m., so 29 minutes away from the launch. So now let's learn about the relationship between launch vehicles and satellites. Mr. Kotani, could you please explain? Okay, so what is launch vehicle? As was mentioned by Mr. Okada, project manager, it is like a delivery service, delivery vehicle to the space. So that is the role of a launch vehicle. So a super fast one, isn't it? Yes, that's right. This Daiichi 3 takes only 17 minutes. So this is a super fast delivery. But what's necessary is a fuel. So this fuel accounts for 90% of the weight of the launch vehicle. Did you know? So yes, you see the vehicle and pretty much all of it is a fuel tank, isn't it? Yes, the orange part is the insulator for the tank. So most of the body is the tank. That's right. Thank you very much. Yes, so could you please talk about the different types of different satellites? Yes, overall communication satellites, weather satellites, and Earth observation satellites. Daiichi is one of them. And also, there are some other types of satellites. So we have Michibiki, which can send you the location data and so on. And weather satellite is, for example, Himawari is one of them. And so this time around, there is a video to introduce Daiichi S3, and also we have an interview video with Mr. Sagisa, who is a project manager.
日々変化する大地の表情を捉え、私たちの社会に役立てる大地の目。大地3号は大地の光学ミッションを引き継ぐ地球観測衛星です。大地からさらに大型化、高性能化した光学センサーを搭載しており、大地の観測幅 70km を維持しながら地上分解能をおよそ3倍向上させ 80cm を実現。 り鮮明な画像が得られます。第一3号は衛星直下の地表面を日々観測し、データを蓄積し続け、年や季節などによる地表面の変化を捉えます。アーカイブされた観測データは世界の高精度な地理空間情報の整備と更新に貢献します。災害発生時には被災地を迅速に観測、多種多様な災害に対応するために複数の観測モードを有し、衛星直下以外の任意のエリアも観測できます。観測されたデータは速やかに地上へ。被災前後のデータを比較し、建物の倒壊や道路の寸断など詳細な被害状況を把握します。地球を見守る大地の目。第一3号は地球の安全と安心のために、そして豊かな社会のために宇宙へ飛び立ちます。
2015年にプロジェクトが開始してから設計・製造を行ってきて、昨年10月に製造が完了し種子島に運んだというところでございます。大企業から下町の小さな工場までいろいろなところの会社さんが関わっているので、正確に人数は分かりませんけれども、だいたい30社以上の方々が関わっていただいております。まずは皆さんにこの映像を見ていただきたいと思っておりますと同時に、自分もぜひ見てみたいと思っております。
Oh, it's getting a bit hot, isn't it? I put off my jacket. So how did you like it, Mr. Kotani? Yes, that's right. So since compared to Daiichi Class, Daiichi S3, the resolution has gone up so much. So when it comes to the resolution, if you use a digital camera, it may be easy to understand. It's like a number of pixels. So that is a 70-kilometer observation range and 0.8 meters. If you compare that to the number of pixels, if you have as many as that, you can recognize a car. I think it's still hard to imagine, but if it's a TV, it's like a high vision, a TV becoming a 4K camera, a TV. So it is quite a evolution, isn't it? Yes, that's right. But if you get a more high resolution data or images, then the amount of data you can take per day increases, but sending that to the ground would be challenging, right? Yes, that's right. Artificial satellites are circulating around the Earth, but the data can only be conveyed above antennas of the base stations. You can have communication with the satellites. So only when they pass above the antennas, you can have the interaction. So you cannot get all the data at once, so you have to wait for the next turn. So that is the challenge we face today. To resolve such a challenge, part of the solution is a optical interaction system. So project manager Yamagawa is going to talk about the technology for the data relay of the Earth observation satellites.
地上から見て常に同じ方向に見える静止軌道衛星光データ中継衛星を用いて、ユーザー衛星と呼ばれる地球観測衛星などより低い軌道を飛行する衛星との通信を中継するシステムです。データ中継衛星を用いた通信システムはユーザー衛星と光データ中継衛星の間、光データ中継衛星と地上の間の2つの通信回線から構成されますが、そのうち、前者の方の通信回線を光通信化したものが、ルーカスの大きな特徴でございます。データ中継システム自身がメリットを持ってまして、広い通信範囲が可能ということでございまして、トータルで送れる通信量が大きくなること、またその広い範囲に対してどこでも、コマンドを打つことが可能ですので、利用範囲が広がることが、期待できます。さらに光データ中継衛星化することにより、光のメリットである高速交代規制とか、またアンテナを小さくできるために機器自体を小さくすることが可能になります。 宇宙光通信、とりわけ技術的難易度の高い衛星間通信という観点では JAXA は欧州の宇宙機関と並び世界のフロントラインに立って軌道上実証を含む研究開発を進めてまいりました。その集大成として、実用に供しうるレベルの光衛星間通信を実証できることがルーカス開発担当としては非常に大きな喜びでございます。加えて特に今回第13号により得られる素晴らしい観測画像の伝送を担い観測データが広く皆様のお役に立っているそのプロセスの一環として寄与できることを光栄に感じております。
So, Kotani-san, what did you think? Like I said, how can we actually transfer large volume of data? If we use a method like this, the large amount of data can be transferred, and I was quite impressed as an engineer myself. So the data that were transferred, how are we going to utilize that in our society? That's going to be a lot of fun to think about. Yes. In regards to those people who are involved in the data usage of Adachi 3 or ALOS 3, we've asked about how they are using that data and how they're distributing data. Please take a look.
パスコは航空写真測量の会社として創業し、今年10月で70年を迎えますが、今では航空機以外にも人工衛星、車両、ドローン等により得られるセンシングデータから地理空間情報を収集し、社会課題や経営課題に対するソリューションを提供しています。パスコは地上運用システムの整備、衛星運用、そしてデータ配布事業を JAXA さんの共同事業者として担います。またデータが広く普及するよう利用事例づくりを進めてまいります。第一3号のデータは地図データの整備、災害対策、スマートシティやスマート農林水産業並びに環境監視等広い分野での利用が期待されております。第一3号で観測したデータは見てみるというパスコのウェブプラットフォームから入手することができます。見てみるでは利用者は関心エリアや観測期間を設定するだけで簡単に衛星データの検索閲覧をすることができ、続いて処理仕様を指定することでオーダーを行うことができます。第一3号から得られる高品質で利用用途の広いデータは衛星データ利用の市場をより一層ダイナミックなものへと変貌させていくと確信しており、私たちがその一役を担うことを楽しみにしています。衛星データが多方面で使われるよう JAXA さんやパートナー企業とともに取り組んでまいります。
土砂災害研究部では豪雨や地震、火山噴火などに起因する土砂災害の被害を防止・軽減するため土砂災害のメカニズムや対策施設の効果的な整備、警戒避難や監視対策などソフト対策に関する研究を行っています。土砂災害は山岳地や丘陵地で発生することが多く、まずどの場所でどのような種類や規模の土砂災害が発生したのかを把握するために第一3号データを使用する予定です。土砂災害分野で特に変わる点としては、やはり災害発生後の初動として重要な被害状況の迅速な把握が可能となることが大きな変化と思っています。近年では気候変動の影響や大規模地震の切迫性が指摘されており、土砂災害の頻発化や激甚化が懸念されているところです。防災・減災、国土強靭化は国を挙げて進めており、第一3号の打ち上げが成功して観測を順調に開始し、災害時には大いに活用されることを期待します。
作成や更新のための技術開発を担う部署です。その一環で衛星データを利用し効率的に地図を更新するための技術開発を行っています。国土地理院が整備している電子国土基本図の更新に第一3号が撮影した画像データを使用する予定です。電子国土基本図はさまざまな地図の基礎となる我が国の基本図で、2021年9月に施行されたデジタル社会形成基本法において公的基礎情報データベースという正確性や最新性が確保された社会の基盤となるデータベースの一つに位置づけられています。大きく4つのステップがあります。ステップ1は測量用航空機による空中写真撮影、次のステップ2が図鑑、地図を描く工程です。ステップ3が現地調査、 最後が編集で図化したデータに市町村名などの中期に関する情報を加えて作業が完成します。第一3号の解像度は初号機の 2.5 メートルから 0.8 メートルに向上しています。分解能が向上し、判読できる地物が増えることは地図の精度向上に直結します。今回第一3号のシミュレーション画像を25000レベルの電子国土基本図で利用可能か評価したところ、海、河川、湖の縁となる水害線や道路、鉄道、建物、植生、土地利用といった基本的な地物についておおむね問題なく判読可能であることを確認しており、ステップ1に加え電子国土基本図の図化にも利用できると期待を寄せています。また第一3号のデータから都市開発などで大きく変化している箇所を自動的に抽出し、電子国土基本図の更新すべきエリアを効率的に選定できるような技術開発にも着手したいと考えています。地図作成に携わる我々にとって待望の打ち上げです。第一3号から国土の様子を捉えた画像が届くのを楽しみにしています。
And many people will be utilizing data from the Daiichi 3 or LS3. I'm very much looking forward to seeing for myself. Now, on this occasion, we invited messages in support of H3 launch vehicle and Daiichi 3 LS3, and these messages are posted onto SRB3, and they're actually attached to the side of the rocket. And so when you're inside the building, you can actually see these messages right in front of you. I saw it myself, but it's in a very visible location, these messages. You can actually read these messages. And so, people are able to feel that, there is a strong interest and there is a strong support, and, they are able to feel a great motivation here. I actually sent in a message myself with my initials. And we have seen the involvement of many companies and organizations as supporters, and they're providing a lot of support through their web pages and through events. Thank you, everyone, for the wonderful support. And the message of support from everyone will also set off to the space with the launch vehicle. So next, we have a video that explains the state of preparation of TH3. And a lot of work, a lot of tests have been conducted thus far. And, bring in the units here and doing the assembly. H2A and B, they also went through more or less the same process, but as I said at the outset, this is quite large. H3 is quite large, and so it was quite a significant amount of work. And towards the end of the VTR, you were able to see H3 being moved, and we were actually there. and we were actually walking right next to it, and I was in tears almost because in anticipation when the A3 was moved. Now, it's actually on top of the launch pad, and beneath the launch pad there is a lorry, a truck that actually will transfer the launch vehicle, and the speed is a little bit slower than people's walking pace, and it's only 400 or 500 meters of travel, so it only takes 30 or 40 minutes for the travel. But when you actually look at it from right next to it, it's quite a grand view. A3 launch vehicle is kind of embedded into the launch section. You may have realized this when you watch the video. And but at the start of the launch, the ignition may not look all that visible, but the launch vehicle is quite large, and the assembly building was we used the same as those for the H2B, and there was an issue with the height, and so we had to actually embed the launch vehicle into the launch pad. Next, we would like to show you a video of the H3 launch vehicle flight sequence.
種子島宇宙センターから打ち上げられる H3 ロケット試験機1号機。ここからはそのフライトシーケンスを紹介します。およそ1分56秒後 SRB3 が分離します。そして3分34秒後フェアリングを分離します。5分5秒後には第1弾第2弾が分離。そして5分17秒後に第2弾エンジン燃焼を開始します。その後もロケットは飛行を続け、打ち上げからおよそ16分57秒後に A-LOS3 が分離される予定です。衛星分離後、第2弾はインド洋上へ制御落下を行います。はい、ここで再び。
So let's take a look at the launch control center, LCC. Well, people do look quite relaxed, and so it doesn't look as though they're in a rush. So they're basically doing their jobs. And we have also a video linkage to Range Control Center, RCC. And each of the tracking station is remotely controlled from here, and they also monitor the state of the vehicle in flight. And in cooperation with LCC, all the command regarding the launch is executed from here. So we have LCC, the Launch Control Center, and the RCC, the Range Control Center. We have these two the control centers. They have different roles. In the case of a launch control room, they are responsible for preparation work towards the launch and also countdown. They are also responsible for RCC, the Range Control Center. They are responsible for tracking the vehicle after launch, and so. There is a ground station, but the operating the ground station is also responsibility under Range Control Center. The launch is imminent, and so from here we're going to utilize the live image from the launch pad and live commentary from RCC.
打ち上げ8分前です。現在、各系ともロケット打ち上げの最終作業を行っています。また、警戒区域の安全は確認されています。
It's 8 minutes to launch. All systems are now in their final operations. The restricted area has been vacated and cleared.
安全系準備完了。
Range safety system is go.
車上系準備完了。
Range system is go.
打ち上げ6分前です。現在、車上の天候は晴れ、気温摂氏15.5度、西南西の風、毎秒0.8メートルです。
It's 6 minutes to launch. The current weather at the launch site is fine. Temperature is 15 degrees Celsius. Wind is 0.8 meters per second from the west-southwest. The weather is still a go, and currently there is no constraint for launch.
本日の打ち上げ予定時刻は日本時間の午前10時37分55秒です。
Today's scheduled liftoff time is 10:37:55 seconds a.m. Japan Standard Time.
打ち上げ5分前です。
It's 5 minutes to launch.
衛星系準備完了。
Satellite system is go.
自動カウントダウンシーケンス開始。
Automatic countdown sequence has been initiated.
現在、ロケットの管制は竹崎発射管制塔から行われています。
A3 is now operated under the command of Takesaki Launch Control Center.
18、17、16、15、14、13、12、11、210、209、208、
2段液体水素地上油圧開始。
Pressurization process of second stage liquid hydrogen has been initiated.
98、97、96、95、94、93、92、91、190、89、88、87、86、85、84、83、82、81、180。
打ち上げ3分前です。
3 minutes to launch.
76、75、74、73、72、71、170、69、69。
1段液体酸素液体水素地上油圧開始。
Pressurization process of first stage liquid oxygen and hydrogen has been initiated.
機体の電源が外部から内部に切り替えられました。
The power has been switched to the internal systems.
51、150、49、48、47、46、45、44、43、42、41、140、39、38、37、36、35、34、33、32、31、130、29、28、27、26、25、24、23、22、21、120、19、18、
2段液体酸素地上油圧開始。
Pressurization process of second stage liquid oxygen has been initiated.
打ち上げ1分前です。
1 minute to launch.
フレームデフレクター冷却開始。
Flame deflector cooling is initiated.
ウォーターカーテン作動淡水開始。フライトモードオン。
Flight mode on.
加工品トーチ点火。
Hydrogen pulse igniter on.
全システム準備完了。
All systems are go for
メイン
launch.
エンジンスタート。
Main engine start.
SRB3 点火。
を伝えるために
企画管理主任より打ち上げ作業関係者に連絡します。ただいまメインエンジンは着火しましたが SRB3 は着火しなかった模様です。現在状況を確認中です。
This is an announcement from the Takesaki Range Control Center to all launch operators and personnel. We have a report that the main engine was ignited, but the SRB3 were not. We are examining the situation.
繰り返します。ただいまメインエンジンは着火しましたが SRB3 は着火しなかった模様です。現在状況を確認中です。
Repeat. This is an announcement from the Takesaki Range Control Center to all launch operators and personnel. We have a report that the main engine was ignited, but the solid boosters were not. We are now confirming the situation.
はい、打ち上がっているはずの時間になりましたが、まだ
So it should have been launched, but the H3 launch vehicle still remains in the launch pad, and there was a broadcast or announcement. Based on the announcement, the main engine was ignited, but SRB3 did not ignite. But we are still confirming facts, and so in regards to what had happened, we will provide you with an official report, but we are still trying to confirm the details, so please bear with us.
SRB3 は着火しなかった模様です。状況確認には時間を要する見込みです。分かり次第、打ち上げ関係者に別途連絡いたします。これをもちまして、本日の H3 ロケット試験機1号機の打ち上げ実況放送を終了します。
This is an announcement from the Takesaki Range Control Center to all launch operators and personnel. The main engine was ignited, but the side boosters were not. It is expected that it will take longer to examine the situation. The status of H3 launch vehicle test flight number 1 will be announced to all launch operators as soon as it will be confirmed. We are ending today's launch status report.
繰り返します。先ほどメインエンジンは着火しましたが、SRB3 は着火しなかった模様です。状況確認には時間を要する見込みです。分かり次第、打ち上げ関係者に別途連絡いたします。これをもちまして、本日の H3 ロケット試験機1号機の打ち上げ実況放送を終了します。
repeat. The main engines were ignited, but the solid boosters were not. It is expected that it will take longer to examine the situation. The status of A3 launch vehicle number 1 will be announced to all launch operators as soon as it will be confirmed. We are ending today's launch status report.
And as was reported, the main engine did ignite, but SRB3 seemed not to have ignited. But specifically, we don't know the reason as to why this did occur. It might take some time, but as a fact, about 6 seconds before the launch, the main engine ignited and it becomes stable. And count 0, SRB3 was to be ignited, but unfortunately it didn't ignite. And we're trying to investigate the reason for this, and so still trying to confirm the details. And we will continue with this live broadcast for a little more while. And if we identify the reason, we will communicate the cause. But we are still trying to confirm the details. So if you could bear with us a little bit more, and this live stream is continuing for a little while more.
はい。まだ新しい情報はこちらに。
We have not been able to obtain any new information at this point in time, but I apologize for having everyone wait. But there was a report before in the broadcast, and they were only talking about what had occurred as a phenomenon. So the main engine did ignite, but SRB3 did not ignite. And this was quite obvious by looking at it as well. What I thought was that normally the main engine, 6 minutes before the launch, would be ignited, and when it becomes stable and when the count is 0, then SRB3 should have been ignited. But it seems that that did not occur, and they are investigating the cause for this. And we were hopeful of being able to communicate the reason, but we are still waiting for updated information. But we are still trying to confirm the situation. And so if you could bear with us, we will still continuing the live stream.
はい、皆様大変。
I apologize for having to make you wait. We have no updated information. And if I repeat, the main engine did ignite, but SRB3 did not ignite. We are still trying to confirm the situation. I repeat, the main engine successfully ignited, but SRB3 did not ignite. And we are still trying to identify the cause. And it would have been nice if we were able to explain what had happened, but it is taking time to identify the true cause, and so it seems that we will not be able to tell you the exact cause. But the main engine did actually ignite 6 seconds before the count was 0. I think you may have been able to see it. At the count of 0, SRB3 should have ignited, but unfortunately that did not happen. And additional information is not expected to be made available within the next few minutes, and so we'd like to conclude the live streaming of the HR3 launch vehicle test flight number 1. More detailed information will be made available on JAXA's website, so please refer to the website. And I truly apologize for those people who were very much looking forward to the launch, but hopefully we'll be able to regroup and go to the launch again. But the detailed information will be made available on the JAXA's the website. Thank you very much for joining us for the live streaming today. Thank you.